Good morning everyone, I am Dr. Nivedita Behra from Department of Marine Science, Colombo University, and today I am going to discuss about how light and sound varies in the ocean and what is the necessity of light. So all of us know the basic source of energy of Earth is Sun. So whatever the energy that flow in our Earth system is from Sun. So and that the heat provided by the sun is redistributed in the ocean by ocean current and in the atmosphere by wind. So basically what happens, the unicellular organism in the ocean takes the sunlight and makes the photosynthesis process, and after that there will be the food of the zooplankton, and then the zooplankton is eaten by the higher organism. So basically whatever the energy is redistributed among the mariners by food or food chain. So basically whatever we consume from the ocean, that is basically the sunlight, and how the light next will be I will discuss about how the sunlight is varying in the ocean from top to bottom. First of all, what happened? The sunlight wouldn't penetrate greater than 1000 meters. So up to certain meter, like 100 meters, what happened? Most of the light is absorbed, and after that only few could be travel beyond 100 meters. Then after that, after 1000 meters, there will be no light. So accordingly, we divided the ocean into 3 parts. First one is UV protection, where 70% of the light will be absorbed. After that, in the despotic zone, where few light will be available. Then air protection. So whatever, if we get the most of the light in the topmost layer, so most of the chlorophyll and most of the unicellular organism takes the sunlight to produce food by the process of photosynthesis, they will be available in the euphotic zone. After that, despotic zone, they may travel up to despotic zone, but most of the chlorophyll will be available in the euphotic zone. After that, what happens? The air protection, where there will be no light. So, and from this figure, it is clear that the euphotic zone is very thin layer of the ocean. Despotic zone slightly greater than the euphotic zone, and the apotic zone is the maximum area of the ocean. Next is how light travel in the ocean. Basically, whatever travel, the interaction of light with the particle, like first one is reflection, second one is scattering, absorption. So what happened? The first one is reflection, like if sunlight fall on the ocean surface of the ocean, they may not penetrate 20%, some might be reflected back, and some of may be penetrate through the ocean surface. If the surface is smooth and calm, then what happens? Most the penetration of the light will be more and the reflection will be less. If the surface will be rough, then what happens? Most of the light will be reflected and penetration of the light will be less. So, and another thing, light travel faster in the water. So the light travel more distance in the air than the water. So after 1000 meters, there will be no light. You can understand from this. So, what do you mean by light? Light is basically the electromagnetic wave consisting of different colors. If you have an idea of this question, then after this question you have an light is consisting of 7 colors. This is can give an example of rainbow. How rainbow comes after refraction of light from the water particle, that will be dispersed into 7 colors. So similarly, the light, which consisting of 7 colors, and each constituent of the light travels in the ocean differently. Like some of the light may travel much deeper than the other. For example, red, yellow, orange, they will travel like 49, 90 to 164 feet. Whereas the violet, blue, green, they may travel more faster, like more deeper in the ocean. So most of the deep ocean is visualized as blue. If you go up in the outer space, then what happens? The Earth looks like blue ball. So how does that happen? Because the blue light penetrates most in the ocean. So and 70% of the Earth is ocean. So Earth looks like it, and it is called as blue planet. Then next, sound. As you know, sound moves faster in the denser medium than the lighter medium. So water is basically more dense than the air, and the velocity of sound in water is about 1500 meters, and in air it is 330 meters per second. So what is we can depict that in 1 second the sound can travel 330 meters in the air, but in 1 second the same sound travel 1500 meters. So, and first I told that denser medium sound travel faster. So in our ocean, how density varies? Density is directly proportional to temperature and salinity. So so we can conclude that sound is dependent on salinity and temperature. This is two figures which is showing, one is temperature variation with respect to depth and one is pressure variation with respect to depth. So what happened? The density is also like that. The top 0 to 500 meters, the density is not the density, the temperature is high, but below 1000 to 1500 the density is high. So what happened? 500 to 1000 meter, there will be the density will be a little bit less because of this pressure temperature variation. So what happened? Whatever the sound produced in this depth, 500 to 1000 meter, they will be traveling between this. And this channel is called as SOFR channel, that is sound fixing and drenching channel. So if some sound is produced here, then it will be go up and bombarded here, because sound couldn't travel from lesser tensor to higher tensor, so it will reflect back. Similarly happen up in the at this depth 1000 meters. So in the next figure it will be clear. So if some sound produced here, it will be amplified and could travel much more distance. So yeah, this is the figure. So this is the source of the sound. It goes up and reflected back, and here is also goes down and reflected back to upward. So we can conclude that so without loss of energy, the sound could travel much farther distance in this channel. So sound travel better through water than the air. The energy required to transmit the sound wave is higher in air than in water. So from the velocity itself, it is clear that for 1 second, in 1 second, sound can travel to 330 meters in air, but in water, what happened? It travel like 1500 kilometers. So very less energy required to travel in the denser medium. So this is an example also given, where 130 decibel in air is about equivalent to 100 meters from the jet engine. At takeoff, a sound of 130 decibel in water is equivalent 70 decibel in air. Like if for example, if a jet is moving, okay, and we will be nearer to that 100 meter of that jet, then what happens? It will burst out again. Okay, but if the same sound will produce within the water, the effect will be very less. Like that, if we produce double of that sound, then only it can affect our ear. So this is all about the variation of light and sound in the ocean. Thank you.